Now there will be many questions on conditions of two lines. So if we have two lines, say x minus x1 upon a1 equals y minus y1 upon b1 equals z minus z1 upon c1. Next is x minus x2 upon a2, y minus y2 upon b2, and z minus z2 upon c2. First one is angle between the two lines, and this we have already discussed. We know that this angle cos theta will be given by a1 a2 plus b1 b2 plus c1 c2 upon under root of a1 square plus b1 square plus c1 square, and then under root of a2 square plus b2 square plus c2 square. So once we have direction ratios of these lines, we can always find angle between them. Now the second question is more important. It is generally asked in the examination, and it is we have to find if these two lines are coplanar. That is, they lie in the same plane. Or they may give you two non-parallel lines they are coplanar, they intersect. So the same question they can be asked in three ways. They'll give you two lines and they'll say these two lines they are coplanar, or these two lines they lie in a plane, or they'll say these two lines they intersect at a point. Two non-parallel lines they'll intersect if and only if they lie in the same plane. All the three conditions they are equivalent. Now we know that in order to check coplanarity we need three vectors. Now we have one vector which is direction of this line a1 b1 c1. We have another vector which is direction ratio of the second line a2 b2 and c2. Now two vectors they are always coplanar, so there has to be this third vector with which we can check coplanarity of these two lines, and this third vector we can always define using points on these lines. So this first point is x1 y1 z1, and this second point is x2 y2 z2. Now we can define this vector as direction ratios between a and b. So it will be this x2 minus x1, y2 minus y1, and z2 minus z1. So these two lines they'll be coplanar if these three sets of vectors they are coplanar, and we know that three sets of vectors they are coplanar if their box product is 0. That means value of this determinant which is formed by x2 minus x1, y2 minus y1, z2 minus z1, and then their direction ratios a1 b1 c1, a2 b2 c2, it must be 0. So if the two lines are coplanar or they intersect, then all we need to do is we need to write points on these two lines, and then first one is x2 minus x1, y2 minus y1, z2 minus z1, and the other two rows are direction ratios of these two lines, and if they are coplanar then this determinant it must be 0. Now say for example we are given two lines x minus 2 upon 1, y minus 3 upon 1, z minus 4 upon minus k, and x minus 1 upon k, y minus 4 upon 2, z minus 5 upon 1, and if they are coplanar we need to find value of k. Now we write point on this line. Now point on this line is 2 3 4, and point on this line is 1 4 and 5. So we'll directly write determinant. Now this is x2 minus x1, 2 minus 1 is 1, 3 minus 4 is minus 1, and 4 minus 5 is minus 1. Now direction ratios here they are 1 1 and minus k, and here they are k 2 and 1. So this is k 2 and 1, and it must be 0. Now what we'll do is we'll write c3 as c1 plus c3 and c2 as c1 plus c2. So it will be this 1 1 k, here will be 0 2 and k plus 2, and here will be 0, 1 minus k and 1 plus k. Now if we expand it about this first row, we can write this as 2 plus 2k minus k plus 2 into 1 minus k, and it should be 0. So this is 2 plus 2k, and here will be this plus k square plus k minus 2 equals 0. Now this 2 and 2 will cancel. So we'll get k square plus 3k equals 0. So value of k is either 0 or value of k is minus 3. So these two lines, they'll be coplanar or they'll intersect if the value of k is either 0 or minus 3, and that's your option 2. Now let us take another question. If these two straight lines with parameter s and t, they are coplanar, find the value of lambda. Now we are given these two equations in terms of parameters. So what we'll do is we'll write this equation in symmetric form. Now here will be x minus 1 upon 1, y plus 3 upon minus lambda, and z minus 1 upon lambda, and the second equation will be x upon 1 by 2, y minus 1 upon 1, and will be z minus 2 upon minus 1. Now we'll find point on this first line. This point is 1, minus 3, 1, and point on the second line is 0, 1 and 2. Now direction ratios here are 1 minus lambda lambda, and this is 1 by 2, 1 and minus 1. So we can write this determinant as x1 minus x2 or x2 minus x1. It doesn't make a difference. So 1 minus 0, it is 1. Minus 3 minus 1 is minus 4, and 1 minus 2 is minus 1. Direction ratios are 1 minus lambda lambda, and here it is 1 by 2, 1 and minus 1. Now what we'll do is we'll write C3 as C3 plus C2. Now this is minus 4 minus 1, minus 5, minus lambda plus lambda is 0. Now this is also 0. Now we expand it about this third column. We can write this as minus 5, and this is 1 plus lambda by 2 equals 0. So value of lambda must be minus 2, and that's your option 3. So we'll be given two equations, then we have to check either they'll intersect or not, or we need to find value of some unknown. Now the question is, if the two lines intersect, then find the value of k. If the lines intersect, then a2 minus a1 dot b1 cross b2 is 0. So we have this vector triple product, which should be 0. Now point on this first line, it is 1 minus 1 1, and on the second line this is 3 k and 0. So we write a2 minus a1, so this is 2 k plus 1 minus 1, and then direction ratios of two lines. So it is 2 3 and 4, and here will be 1 2 and 1. Now we expand this determinant, we'll get 2, and this is 3 minus 8, so it will be minus 5. Now next one is 2 minus 4 minus 2, so it will be plus 2 k plus 1, and then it will be 4 minus 3, so it is minus 1 equals 0. So we'll get this as 2k, and this is minus 11 plus 2, which is minus 9. So value of k is simply 9 by 2, and that's your option B. Now the question is, we need to find non-zero value of a for which this line and this other line, they are coplanar. Now what we'll do is, from the second set of equation, we'll find point and direction ratios of this line. Now if we put x as 0, we'll get minus 3y plus z equals 0, and here will be 2y plus z plus 1 equals 0. Now z is equal to 3y, so we'll get y as minus 1 by 5, and z will be minus 3 by 5. So one of the point on this line will be 0, minus 1 by 5 and minus 3 by 5. Now we can also find direction ratios of this line. Now for direction ratios, all we need to do is we just need to take its cross product. So this is I, j and k, and this is 1, minus 3, 1, and here will be 1, 2 and 1. Now what we'll do is we'll write R3 as R3 minus R2. So it will be 0, 5 and 0. Now if we expand it, we'll get minus 5, and here will be I minus k. So direction ratios of this line, they are 1, 0 and minus 1. So now we have this point and we also have this direction ratio. Now we'll find one point on this first line. Now for this first line, what we'll do is we'll put x as 0, and if we put x as 0, we'll get minus y plus 3z plus 4 equals 0, and here will be y minus z plus 2 equals 0. Now if we add them, we'll get 2z plus 6. So value of z is minus 3, and if we put z as minus 3, we'll get y as minus 5. So one of the point on this line will be 0, minus 5 and minus 3. Now we'll find direction ratios of their point of intersection. So it will be I, j, k, and here it is 2, minus 1, 3, and this is a, 1 and minus 1. Now we solve this, we'll get 1 minus 3, there will be minus 2i, and here will be minus minus plus 2 plus 3a into j, and then plus 2 plus a into k. So now we have direction ratios of this second line also. Now if these two lines, they are coplanar, then this determinant, which is x2 minus x1. Now x2 minus x1 is 0 minus 0, and then minus 1 by 5 plus 5. So there will be 24 by 5, and then 3 by 5 plus 3. 15 minus 3 is 12 by 5. And then their direction ratios for this first one, they are 1, 0 and minus 1. And for the second one, they are minus 2, 2 plus 3a, and then 2 plus a. The value of this determinant, it must be 0. Now from this first row, we'll take 12 by 5 common, and then we'll add C3 with C1. So it'll be 0, 2 and 1. This is 1, 0, 0, and here will be minus 2, 2 plus 3a, and then a, and it must be equal to 0. Now if we expand it about this second row, we'll get minus 1 and then 2a, minus 2, minus 3a equals 0. That is, value of a is minus 2. So these two lines, they'll be coplanar if the value of a is minus 2. And that's your option A. Now third question in this could be to find point of intersection of two lines. Now if the two lines are coplanar and they intersect, then basically we can find their point of intersection, say P. Now we are given this first equation, which is x minus x1 upon a1 equals y minus y1 upon b1 equals z minus z1 upon c1, and here this is x minus x2 upon a2, and this is y minus y2 upon b2, and it is equal to z minus z2 upon c2. Now we need to find whether these two lines, they are coplanar or they intersect, and if they intersect, we need to find their point of intersection. Now in order to check and to find the point of intersection, what we'll do is we'll write an arbitrary point on this line in terms of parameter lambda. So any point on this line, we can write this as x1 plus a lambda, y1 plus b lambda, and z1 plus c lambda, and we'll take up an arbitrary point on the second line in terms of another parameter, say t. So we can take this as x2 plus a2t, y2 plus b2t and z2 plus c2t. Now this point of intersection, it will lie on both the lines. So there will be this one point which will lie on both the lines. So what we'll do is we'll try and find this point. So we'll equate these two coordinates. Now we compare their x coordinates. We can write x1 plus a lambda, it is equal to x2 plus a2t. Now next one is y1 plus b lambda, it is equal to y2 plus b2t, and z1 plus c lambda is equal to z2 plus c2t. Now basically these are three linear equations in lambda and t. Now to find whether these two lines they'll intersect or not, we have to check consistency of this system of equations. And for this what we'll do is we'll solve any two linear equations and we'll find the value of lambda and t. And if value of lambda and t it satisfies this third equation, then this system of equation is consistent. In that case, these two lines they'll intersect at a point. And to find this point of intersection, we can choose either lambda or t, because both of them they'll give us the same point. Now the fourth one on this is if these two lines are coplanar, then they may also ask us to find equation of plane containing these two lines. We'll discuss this fourth case when we'll study equation of a plane. Now here the question is, if the three lines are concurrent, then we need to find the value of h and k. So what we'll do is, we'll first solve these two lines and then we'll find their point of intersection. So a general point on this first line will be lambda, 2 lambda and 3 lambda, and it'll be equal to a general point on the second line, say in terms of parameter t, and which is 3t plus 1 minus t plus 2 and then 4t plus 3. Now we equate them, we'll get lambda minus 3t, it is equal to 1. T plus 2 lambda, it is equal to 2. And then 3 lambda equals 4t plus 3. And we'll multiply this first equation with 2. So it will be 2 and then 6 and then 2. And then we'll subtract first from second. So 2 lambda will cancel. This plus 2 minus 2 will also cancel. We'll get the value of t as 0. So value of t is 0. And if you put t as 0, we'll get lambda as 1. Now if we put t as 0 and lambda is 1, it satisfies this third condition. So that means these two lines, they'll intersect, and they'll intersect when the value of lambda is 1 or when the value of t is 0. So their point of intersection, it will be 1, 2 and 3. Now once we have this point of intersection, these three lines, they'll be concurrent if this third line, it will also pass through this same point. So we'll put x as 1, y as 2 and z as 3. So we put x as 1, so it will be 1 plus k upon 3 and it will be equal to 2 minus 1, which is 1 by 2, and it will be equal to 3 minus 2, 1 by h. So from here we can write value of h is 2 and value of k is 3 by 2 minus 1, which is 1 by 2. So these three lines, they'll be concurrent if h is 2 and k is 1 by 2, and that's your option D. Now here the question is, the equation of two straight lines are given. Now statement 1 is the given two lines are coplanar, and the second one is the equations are consistent. Now on this first line, we'll take this point as r. So we can write this point as 2r plus 1, r minus 3 and minus 3r plus 2. And on the second line, we'll take this point in terms of s. We can write this point as s plus 2 minus 3s plus 1 and 2s minus 3. Now, if these two lines, they'll intersect, then we'll have this one point where both the coordinates, they'll be same. So we'll get three equations, and which are 2r minus s equals 1, r plus 3s equals 4, and 3r plus 2s, which is same as this equation 2 or statement 2. Now we'll see if this system of equation is consistent. I will multiply this first one with 3, so we'll get 6r minus 3s and it'll be equal to 3. Now if we add them, we'll get 7r equals 7. So value of r is 1, and if value of r is 1, value of s is also 1. Now if we put r and s here, 3 plus 2 is 5. So this system of equation is consistent and the value of r and s is 1. And if the system of equation is consistent, then these two lines, they intersect at a point. So both the statements, they are correct, and statement 2 is a correct explanation of statement 1. So the answer is this option A. Now here the question is, a line L passes through origin is perpendicular to the two given lines. Now for L1, direction ratios are 1, 2 and 2, and for L2, direction ratios are 2, 2 and 1, which are basically coefficients of T and coefficients of S. Now since our line is perpendicular to both, then direction ratios of this line, it can be given by this cross product ijk 1, 2, 2 and then 2, 2, 1. Now we solve this, we'll get this as minus 2i plus 3j and minus 2k. So basically we can write direction ratios of this line L as 2, minus 3 and 2. So now we have direction ratios of this line, and this line also passes through origin. So equation of this line L will be x upon 2, y upon minus 3 and z upon 2. Now we need to find point of intersection of L with L1. Now any point on L1, we can write it in terms of this parameter t. So point on L1, it is 3 plus t minus 1 plus 2t and 4 plus 2t. It will be same as the point on this line L. Suppose it is in terms of lambda, which is 2 lambda minus 3 lambda and 2 lambda. Since this point of intersection will lie on both the lines. Now if we equate these 2 lambdas, then we can write 3 plus t equals 4 plus 2t, that is value of t is minus 1. And if we put t as minus 1, we'll get value of lambda as 1. Now if we put t as minus 1, this is minus 3 and this is minus 3. That means these two lines, they'll intersect, and their point of intersection, it will be now 3 minus 1, 2. This is minus 1, minus 2, minus 3. And then 4 minus 2 is 2. Now we need to find coordinates of points on L2 which are at a distance of root 17 from this point. Now any point on L2, we can write it in terms of this parameter S. So let this point be P, and it is 3 plus 2s, 3 plus 2s and then 2 plus s, and let this point be Q. Now we are given that this PQ is under root 17. Now if we write PQ, it will be this under root of, now 3 plus 2s minus 2 will be 1 plus 2s whole square plus 6 plus 2s whole square, and here will be plus s square, and it will be equal to under root 17. Now we square it, we can write 1 plus 4s square plus 4s plus 36 plus 4s square plus 24s plus s square equals 17. So it will be this 9s square. Now this is 4 and 24 plus 28s, and here will be 37 minus 17, which is plus 20 equals 0. Now this is 9s square plus 18s plus 10s plus 20 equals 0. So we'll get 9s plus 10 or s plus 2 equals 0. So either the value of s is minus 10 by 9 or the value of s is minus 2. Now if we take s as minus 2, then we can write this point as 3 minus 4 minus 1, and then 2 minus 2 will be 0. So it will be minus 1, 0. That's your option B. And if we put s as minus 10 by 9, then in that case, this point will be 3 minus 20 by 9, which is 7 by 9. Next one will also be 7 by 9. And then it will be 2 minus 10 by 9, which is 8 by 9. And that's your option D. So the 2 points on this line L2, they are minus 1, 0, and 7 by 9, 7 by 9, and 8 by 9. The correct options are B and D. Now if two lines, they are non-coplanar, then they do not intersect. So such lines are called as skew lines. So here we will be given equations of two lines such as x minus x1 upon a1 equals y minus y1 upon b1 equals z minus z1 upon c1, and this equation is x minus x2 upon a2, y minus y2 upon b2 equals z minus z2 upon c2. And these two lines, they are non-parallel, non-intersecting. We have to find shortest distance between these two skew lines. So the question will be, find the shortest distance between these two lines. Now shortest distance between these two lines, it will occur along a line which is perpendicular to both the lines. So we have to find this distance D. What we'll do is, we'll use projection to calculate this. Now suppose direction of this vector is B1 and direction of this vector is B2. Then direction of this shortest line will be this vector B, which is perpendicular to both B1 and B2. Now since this B is perpendicular to both B1 and B2, we know that any vector which is perpendicular to two given vectors, it is given by this cross product. So we can write this vector B as cross product of B1 and B2. So we can write this as this determinant ijk, and here will be this A1, B1, C1 and A2, B2 and C2. And we'll solve this. We'll get this as sum AI plus BJ plus CK. So all we need to do is, we need to find direction ratios of this line of shortest distance A, B and C. Now we'll define a vector from this one line to another line. Now we know that a point on this first line, it is x1, y1, z1, and this point is x2, y2 and z2. And if we take projection of this vector, say AB on this perpendicular, then this projection is equal to D. So basically this D is mod of AB dot B cap. Now B cap means we need direction cosines. So from these direction ratios, we can find direction cosines, and these direction cosines are L, M and N. So we now have direction cosines L, M and N. Now we need projection of this vector on B, and we know that this projection is given by x2 minus x1 L plus y2 minus y1 M plus z2 minus z1 into N, and this is the shortest distance between two skew lines. So the first step is find direction cosines of this line of shortest distance using cross product, and then define this vector AB using the 2 points, and then the shortest distance will be x2 minus x1 L plus y2 minus y1 M plus z2 minus z1 N. And if you want, we can write it in vector form also. Now suppose point on this first line is vector A1, and position vector of point on the second line is A2, then we can write this perpendicular distance as A2 minus A1 dot B cap, or we can also write this as A2 minus A1 dot B1 cross B2 upon mod of B1 cross B2. But still, it is better to find this vector B using cross product and then taking dot product of A2 minus A1 with B cap. So it will give us this perpendicular distance between two skew lines. Now the question is the distance of this point from plane passing through this point. And this question, I think they forgot to mention the two given lines. Now L1 is given as x plus 1 upon 3 equals y plus 2 upon 1, and it is equal to z plus 1 upon 2, and L2 is given as x minus 2 upon 1, y plus 2 upon 2, and z minus 3 upon 3. So now we have this complete question. So we are given two lines L1 and L2. Now the next one, it says find the shortest distance between L1 and L2. Now for shortest distance, first we'll find this n, which is B1 cross B2. Now since we have already taken B1 and B2, we know that its cross product will be minus I minus 7j and plus 5k. Now we need its unit vector. Now unit vector in the direction of perpendicular to both lines L1 and L2 will be minus I minus 7j plus 5k upon under root 75, which is 5 root 3. Now we need to find A2 minus A1. Now point on this line is minus 1, minus 2, minus 1, and here this point is 2, minus 2 and 3. Now we can write A2 minus A1 as 3i plus 0j plus 4k. Now this shortest distance is mod of A2 minus A1 dot n cap. Now we take this dot product, it will be this minus 3 plus 20 upon 5 root 3, which is 17 upon 5 root 3, and that's your option D. Now this third one is a unit vector perpendicular to both L1 and L2, and this we have already done, so it will be minus I minus 7j plus 5k upon 5 root 3, and that's your option B. Now in skew lines there is another question, and which is they may ask us to find equation of this line of shortest distance. So we'll be given these two lines x minus x1 upon a1 equals y minus y1 upon b1 equals z minus z1 upon c1, and this is x minus x2 upon a2, y minus y2 upon b2, and z minus z2 upon c2, and this is line AB, which is line of shortest distance between the two given lines. They may ask you to find coordinates of these points A and B, or they'll ask you to write equation of this line AP. Now this point A, it lies on this first line, and we can take it in terms of this parameter lambda. So here this point A will be x1 plus a1 lambda, y1 plus b1 lambda, and z1 plus c1 lambda. Now we can take this point B in terms of parameter say t. So this point B will be x2 plus a2t, y2 plus b2t, and z2 plus c2t. Now here we have two unknowns, lambda and t, and for this we need two conditions, and the two conditions are this line AB is perpendicular to L1, it is also perpendicular to L2. So what we'll do is we'll write direction ratios of this line AB, and it'll be given by x2 plus a2t minus x1 minus a1 lambda, y2 plus b2t minus y1 minus b1 lambda, and z2 plus c2t minus z1 minus c1 lambda. Now direction ratios of line L1, they are a1, b1, c1. So we'll get direction ratios as a1, b1, c1. Now since AB is perpendicular to L1, their dot product will be 0. So x1, x2 minus x1 will be 0. So we'll get our first linear equation in lambda and t. And this AB, it is perpendicular to L2, whose direction ratios are A2, B2, C2. Again, A1, A2 plus B1, B2 plus C1, C2 equals 0. We'll get our second linear equation. And we solve these two linear equations, we'll get the value of lambda and t. So once we have lambda, we can write this coordinate of A. With t, we can write coordinate of B. And once we have A and B, we can write equation of this line of shortest distance. So this condition is little lengthy, but still we can find it. Now the question is, we are given two lines, L1 and L2. Now L1 is x minus 3 upon 3, y minus 8 upon minus 1, and z minus 3 upon 1, and L2 is x plus 3 upon minus 3, y plus 7 upon 2, and z minus 6 upon 4. Now it says A and B are 2 points on L1 and L2 such that AB is perpendicular to both L1 and L2. So we have this line AB, which is perpendicular to both the lines. Now we need to find coordinates of A and B, and we also need to find shortest distance between L1 and L2, which is given by this distance AB. Now since this point A, it lies on this first line, we can write this A in terms of lambda. So coordinate of this point A will be 3 lambda plus 3 minus lambda plus 8 and lambda plus 3. And for the second line, we'll take this parameter as t. So here it will be minus 3t minus 3 and then 2t minus 7 and 4t plus 6. Now we'll write direction ratios of AB. Now direction ratios of AB, they'll be 3 lambda plus 3t plus 6. Here will be minus lambda minus 2t plus 15, and here will be lambda minus 4t minus 3. So now we have direction ratios of AB. Now this AB, it is perpendicular to this line L1, and direction ratios of L1 are 3, minus 1 and 1. So basically the dot product, it should be 0. So we'll get 9 lambda plus 9t plus 18 plus lambda plus 2t minus 15 plus lambda minus 4t minus 3. It should be 0. So we'll get this as 9, 10 and 1, 11. So it will be 11 lambda. Now this is 9t plus 2t, 11t. 11t minus 4t is plus 7t. And here it will be 18 minus 18. So it will be 0. So we get our first condition that 11 lambda plus 7t, it must be 0. And that's our first equation. Now this AB, it is also perpendicular to L2, and direction ratios of L2 are minus 3, 2 and 4. So again dot product is 0. So we'll get minus 9 lambda minus 9t minus 18 minus 2 lambda minus 4t plus 30 and plus 4 lambda minus 16t minus 12 equals 0. Now this is minus 9 lambda minus 2 lambda and plus 4 lambda. So it will be minus 7 lambda Now this is minus 9t minus 4t, minus 13t, minus 13 and minus 16. So it will be minus 29t and it will be 18 minus 12. 30 minus 30 is 0. So we have our second equation in lambda and t, and if we solve these, we'll get lambda equals to 0 and t equals 0. Now if we put lambda as 0, we'll get coordinate of A as 3, 8 and 3. That's your option B. And if we put t as 0, we'll get B as minus 3, minus 7 and 6. And that's your option A. Now we need to find this shortest distance, which is AB. Now if we use distance formula, then AB will be given by under root of, now this is 6 square 36 plus, now this is 8 plus 7 15, 15 square is 225 and plus, now this is 3 square is 9. So it will be under root of 270 and which is 3 root 30, and that's your option C. Now here the question is, let L1 and L2 denote these two lines. Now this L1, it is given as R equals I plus lambda minus I plus 2j plus 2k, and then we have this line L2 which is mu 2i minus j plus 2k if L3 is a line which is perpendicular to both L1 and L2. So we have this third line L3 which is line of shortest distance. Then which of the following option describes L3? So we need to find equation of L3. Now what we'll do is we'll write this point as A and this point as B. Now this A, it lies on this first line. We can write it in terms of parametric coordinates. So it'll be 1 minus lambda, 2 lambda and 2 lambda, and this B in terms of mu. So it'll be 2 mu minus mu and 2 mu. Now we can write direction ratios of AB. Now direction ratios of AB, there will be 1 minus lambda minus 2 mu, it will be 2 lambda plus mu, and it will be 2 lambda minus 2 mu. Now this AB, it is perpendicular to this first line whose direction ratios are minus 1, 2 and 2. That means dot product of these two direction ratios, it must be 0. So we can write minus 1 plus lambda plus 2 mu plus 4 lambda plus 2 mu plus 4 lambda minus 4 mu, it must be 0. Now here mu and mu will cancel. Now we'll get this as 9 lambda equals 1. So value of lambda is simply 1 by 9. Now once we have lambda, we can write coordinate of this point A will be 1 minus 1 by 9, 8 by 9 and then 2 by 9 and 2 by 9. Now this AB is also perpendicular to this second line whose direction ratios are 2, minus 1 and 2. So again this dot product, it should be 0. So again we can write A1, A2. So it will be 2 into 1 minus lambda minus 2 mu minus 1 into 2 lambda plus mu and plus 2 into 2 lambda minus 2 mu, it must be 0. Now we'll get this as 2 minus 2 lambda minus 4 mu minus 2 lambda minus mu plus 4 lambda minus 4 mu equals 0. Now 2 lambda and 4 lambda will cancel. We'll get this as 9 mu equals 2. So value of mu is 2 by 9. And once we have value of mu, we can write coordinate of this point B. It will be 2 mu, which is 4 by 9 minus mu minus 2 by 9 and 2 mu, which again is 4 by 9. So now we have coordinates of these 2 points A and B. Now once we have AB, we can write direction ratios of AB, and direction ratios of AB will be 8 by 9 minus 4 by 9, and there will be 4 by 9. This is 2 by 9 minus 2 by 9, 4 by 9, and this is 2 by 9 minus 4 by 9, and there will be minus 2 by 9, which is proportional to 2 to n minus 1. So direction of this line L3 will be 2i plus 2j minus k, and which is direction all the 4 given equations. Now we can write equation of this line AB in terms of this point A. So then it will be this R, and then 2 by 9 will be 4i plus j plus k and plus some parameter t, and then this vector which is 2i plus 2j minus k, and that's your option A. Or we can write it in terms of this option B. Here we'll take 2 by 9 common. So we can write this equation as 2 by 9, and this is 2i minus j plus 2k and plus t, 2i plus 2j minus k, which is your option C. Now we need to check other two options. So we'll write this equation in scalar form. So we can write this equation as x minus 8 by 9, y minus 2 by 9, and z minus 2 by 9, taking this point A upon direction ratios of AB, which is 2, 2 and minus 1. So it is 2, 2 and minus 1. For this option D, we need to check whether origin satisfies this equation. Now we put x, y and z as 0. They are not equal. So origin doesn't satisfy this equation. So that means this option D is incorrect. Now in this case, point is 2 by 3, 0 and 1 by 3. Now if we put x as 2 by 3, it will be 2 by 3 minus 8 by 9, 6 by 9 minus 2 by 9. So it will be minus 1 by 9. If we put y as 0, it will be minus 1 by 9. And if we put z as 1 by 3, we'll get this as 3 by 9, which again is minus 1 by 9. So this point, it lies on this line. So the correct options are A, B and C. Now we have this third case when we have parallel lines. Now two parallel lines, they are always coplanar. So in this case, lines are coplanar, but still they don't intersect. Let this line be x minus x1 upon A, y minus y1 upon B equals z minus z1 upon C, and this line is x minus x2 upon A, y minus y2 upon B, and this is z minus z2 upon C. Now we need to find perpendicular distance between these two parallel lines, and for this what we'll do is we'll define a vector in between these two lines. Now say this point is A and this is x1, y1, z1, and this is say B, which is x2, y2 and z2. Now suppose position vector of A is A1 and position vector of B is A2, and direction of these lines, they are B. Now we know that perpendicular distance, it is given by this vector, which we can write A2 minus A1 cross B cap and its magnitude. So all we need to do is we need to define this vector A2 minus A1, and then we need to take its cross product with B cap, and then we have to find its magnitude to find distance between parallel lines. Now say for example, we are given two parallel lines, and let the first line be R equals I plus j plus 2k plus lambda I plus j plus k, and the second line is I plus j minus k plus lambda, suppose I plus j plus k. Now since we have same direction ratios, the two given lines, they are parallel and thus coplanar. Now this is A1 and this is A2. So we'll find A2 minus A1. So vector A2 minus A1 is 0i plus 0j minus 3k, and B is I plus j plus k. Now b cap will be I plus j plus k divided by root 3. First we'll find cross product between a2 minus a1 and b cap. So a2 minus a1 cross b cap will be given by this determinant ijk. Now this is 0, 0 and minus 3. Now here we'll take 1 by root 3 common. Then it will be 1, 1 and 1. Now we'll expand this determinant about this second row. So here will be this 1 by root 3. Now minus minus will be plus 3 and then here will be I cap minus j cap. Now this shortest distance between these two lines will be given by mod of a2 minus a1 cross b cap and will be this root 3 and then magnitude of this value is root 2. So distance between these two parallel lines is under root 6.